Hello, everyone, and welcome to this Science 20 panel discussion titled Foresight, Science for Navigating Critical Transitions. My name is Yara Rajah, and I'm the Chief Advocacy Officer of the Science 20. Thank you very much for joining us today. In this session, we will shed light on the Science 20, its task forces, and its key recommendations. We will be also exploring evidence-based foresight as a central theme for S20 Saudi Arabia this year, as well as exploring the final statement and recommendations of the S20, also sharing some insights from the 4 S20 task forces. As you can see, we have a wonderful panel and critical topics to discuss today. But before we start, let me just give you a little background and context on the Science 20. Briefly highlighted in the opening video, the S20 engagement group is comprised of the National Academies of Sciences of the G20 countries. It is a fairly young group. The S20 was started in 2017 during Germany's G20 presidency, and since then, the S20 continued through the presidencies that followed: Argentina, Japan, and now Saudi Arabia. The main objective and goal of the Science 20 is to develop and advocate for science and evidence-based policy recommendations on key global issues. And that advocacy is targeted mainly towards decision makers, specifically G20 leaders. This year, under Saudi Arabia's presidency, the S20 theme is, as this session is titled, Foresight, Science for Navigating Critical Transitions. This S20 theme was selected with the aim of defining a compelling science agenda within the broad horizon of the Saudi G20 presidency. As we all know, this year the G20 presidency is themed around realizing opportunities of the 21st century for all, and the S20 is specifically trying and attempting to bring the lens of science to address the G23 priority areas of safeguarding the planet, empowering people, and shaping new frontiers. This year, the S20 cycle builds on the previous S20 topics by prioritizing examination of human health, the environment, and the digital technology in the context of a vision for science-based foresight. This science-based foresight provides the path to solving or avoiding future impending disruptions, and aim to better equip and support decision makers to develop future-ready policies. The S20 advocates for foresight as an enabling and impactful approach across these interconnected areas. The current S20 focus on evidence-based foresight, of course, maps the path forward and hopefully reinvigorate the renaissance for science-based foresight. And as we all know, despite the challenges in this exceptional time in history, the science community came together, persevered, and delivered. The S20, through its 10 science-driven recommendations, sought to shape and secure the path forward for science's ability to deliver societal, environmental, and economic benefits. And well, we have, as I mentioned, we have a great panel today. We're happy and proud to have with us 4 young and emerging Saudi scientists with impressive credentials, who throughout the S20 process were instrumental players in their respective task forces. Let me introduce them. We have with us for the S20 Future of Health Task Force, Dr. Farah Al-Ammari. Dr. Farah holds a PhD in neurogenetics from the University of Oxford and is currently a postdoctoral research scientist at King Abdullah International Medical Research Center. We also have for the S20 Circular Economy Task Force, Dr. Burhan Saifuddin. Dr. Burhan is an assistant professor with the Energy and Water Institute at King Abdulaziz City for Science and Technology. Dr. Burhan received his PhD in Material Science and Engineering from the University of California at Santa Barbara. And for the S20 Digital Revolution Task Force, we're happy to have with us Dr. Ahmed Al-Abd Al-Karim, who is currently the CAC's director of the Center for Complex Systems, a joint center between King Abdulaziz City for Science and Technology and MIT. Dr. Ahmed earned a PhD from MIT in computational science and engineering. And lastly, but definitely not least, for the S20 Foresight Task Force, we have with us Dr. Saleh Al-Baik. Dr. Saleh is currently an assistant professor at the Center for Complex Systems at CAXT, and Dr. Saleh has received his PhD in systems engineering from the University of California, Berkeley. And without further ado, let me start by welcoming our panelists again. And I would like to just go around and hear from everyone about your experience and insights on your respective task forces. And if you could also, on the way, highlight some of the key final outcomes of your S20 task force and how did such recommendations were reached. We will be starting with the future of health with Dr. Farah. Dr. Farah, the floor is yours.
Thank you very much, Yara, for the introduction, and I'm very honored to be part of this panel. So there are many critical transitions that had occurred recently worldwide that are affecting our global society, and some of them are affecting the future of human health. And our role as scientists in the Future of Health Task Force is to identify these transitions and challenges that we may encounter to respond to such transitions, and also propose recommendations and solutions to policymakers that could alleviate any disruption that could affect the future of our health. So the first transition that we identified is the transition that we're living in now. Prolonged pandemics, similar to the COVID-19 pandemic, that could occur in the near future. Also, repetitive outbreaks around the world every once and then there is an outbreak in certain areas like Ebola, MERS, yellow fever outbreaks that happened in the past. Outbreaks, prolonged pandemics, they all lead to disruptive and overwhelmed healthcare system. So we need to respond urgently to such a transition. However, there are so many challenges that we encounter when it comes to responding to these transitions. For example, we still have a lack of awareness on emerging disease, a lack of new therapeutics, lack of international collaboration, for example, coordination and limited complementarity between countries. We still have inadequate data sharing and still have inadequate standardized data collection methods. We recommended and urgently recommended policymakers to establish an internationally collaborative pandemic preparedness framework or a plan to monitor and rapidly responding to any emerging critical diseases and handling any future pandemics by empowering scientific networking, communication, sharing of reports, sharing of data and best practices, or any knowledge that was gained during the response to this pandemic. So I believe Saudi Arabia this year has played a vital role during its G20 presidency to encourage collaboration and coordination between countries worldwide to respond to this pandemic in a better way or any universal crisis as well. The second critical transition that we identified as well is that we find that healthcare is moving towards advanced and personalized care. So we recommended that the importance to promote for advanced therapy and similar to omics technologies, any technology that is tailored to the person's or individual's genetic profile. But still, many challenges that we encounter when it comes to advancing such therapies. Like, for example, we still have scarcity of health science talents. We still have insufficient funds and investment devoted to cutting-edge health research projects. We need to invest in raising highly skilled personnel. We still need to invest in training programs that will lead to better development of new innovations for the future. We need to improve regulations to include any new techniques in health plans. And the third critical transition that we identified is that we find that many countries are going through significant demographic shifts due to reduced birth rate, migration, urbanization, and most importantly, aging population. The United Nations has estimated a global average life expectancy of 72.6 years for the year 2019. The global average in the year 1950 was only 65, and they estimate that in the year 2050, it will reach 85. So the potential application from such demographic shift include increased healthcare expenditure, increased demands on healthcare services. So we recommend to deploy urgently policies and interventions to address the challenges arising from such a shift. We need to focus more attention and resources on preventive care and treatment plans, especially for the elderly. So these are the major critical transitions we have identified. There are still many transition as well that we worked on, but there is an urgent need to deploy regulations and policies to respond to these major ones as soon as we can. Thank you.
Wonderful. Thank you very much, Dr. Farah. Now let's see and hear from Dr. Burhan. Could you tell us more about the Circular Economy Task Force?
Thank you, Yara. So the second task force goal was to understand the challenges of circular economies around the world in important sectors. So what is the idea of circular economy? Traditional economic activity focused on linear processes that generate a lot of economic growth and development, but it generated a lot of waste and polluted the environment. The focus was on short-term economic activity, so maybe 10 to 20 years. In contrast, circular economy aimed to reduce waste on a system level and support reuse and continual use of resources. So in a circular economy, waste products are used to make new products or give the old products a second life, like an old car battery, given a second life and used in less demanding application, or to even recover the raw materials that went into making these products. So this needs to be on a systematic level and across several industries. This supports sustainability and living in harmony with the environment. Remember that nature is cyclical. We live under the auspices of the water cycle, carbon cycle, nitrogen cycle, dirt cycle, etc. So there is a need to action to get there, but there are challenges. Over the next few years in the 21st century, if we want to keep growing in a sustainable way while having healthy population growth, reducing poverty around the world, we are going to use much more resources than any time we had in history. So in energy, we need to use fossil fuel, but right now we don't capture the CO2 emitted. So if we capture it, we will achieve a circular economy. These are products, maybe, but still, we're going to generate large amount of them. It needs to be recycled. We're going to use more materials and petrochemicals, plastics. This needs to be recycled. We are going to use more water, more food. So, based on input surveying the G20 National Science Academies, this task force, which was headed by Dr. Yusuf Al-Yusuf from CACS and Dr. Sherry Moray, recognized many challenges for achieving circular economy and important products. And I'm going to tell you about 7 now, very briefly. So, find viable technologies to either give products a second life or extract the raw materials or to make new products from them. A second point was that to devise economic incentives aligned with market forces to push towards circular economy. We also need to develop indicators that assess the quality of circular economies across different countries and across different industries. We need to spread awareness and consciousness everywhere, from school kids to government and corporate leaders around the world. We need to improve the collaboration between governments, private sector, academic institutions, as well as between countries. We also need to increase the funding and investment devoted to sustainable production to achieve circular economy. Lastly, and most importantly, we need to collect data, scientific data about the technologies we have right now and the market, and think and use them to achieve and promote circular economy. So based on all of these challenges, the task force came up with 2 main recommendations to help respond to these challenges. So the first one was about developing an integrated and a closed-loop system for manufacturing important products that capture the whole value chain, from natural resource extraction to manufacturing to distribution, consumption, disposal, and to recycling. The second recommendation was to promote the circular design of materials and energy systems by advancing the 3 R's, which resources, reuse, products, recycled, plus renewables aimed at near zero emission. So this involved creating economic feasibility studies and life cycle assessment of new technologies. For example, new technologies like carbon capture technology and electric batteries and solar cells. And back to you, Yara.
Wonderful. Thank you so much, Dr. Burhan. And now let's hear from Dr. Ahmed Al-Abdelkarim, and where he will tell us more about the Digital Revolution Task Force. Ahmed, Dr. Ahmed.
Thank you so much, Yara. So I think the Digital Revolution Task Force had a big challenge of looking at all of the different issues faced by the different nations. And we had an opportunity of working with different science academies to look at the digital revolution at a global view and discussing the biggest issues that are faced, especially in combating critical transitions, such as the one we're going through right now. During this process, we tried to look at what are the biggest recommendations that could actually assist in not only enhancing the digital revolution, but making it even assist in the robustness of our societies. So the first recommendation, which is very fitting that it fits with the theme of the G20 for this year, which is the theme of realizing opportunities for the 21st century for all. And that for all part is what we try to focus on. The first recommendation, looking at bridging the digital divide gap. Of course, that looks at both the quantity and quality. With regards to quantity, of course, connectivity is a big factor, making sure that more people of our societies around the world are getting connected. But at the same time, other technologies are important. We've seen how right now with online learning, people that have better equipment have better access, and knowledge should be a right for every human being. And therefore, making sure that coverages of a wide variety of technologies are increased. At the same time, quality is important. So making sure that we have better connectivity speeds and so on, because a lot of these technologies require more resources, more computation, more data transfer ability. And therefore, in order to enhance the digital revolution, these requirements have to be tackled. This is the first recommendation. The second one was about the multidisciplinary nature of a lot of the advancements and how you really need to have multiple experts from different domains. Not, for example, you can have a telecom expert with a data scientist and an AI expert, and even having an ethics professor giving some recommendations, given the fact that these technologies are affecting our lives in a wide variety of ways. And all of that put together is really about the second recommendation of multidisciplinary research. The third and last recommendation is about improving sustainability. And this has two basic pillars. The first is sustainability of our cities and our societies, so making sure that the digital revolution technologies are helping in that effect. And of course, smart city technologies are a big factor in that. But at the same time, one of the biggest issues is the technologies themselves being sustainable. We've seen many examples of smart city infrastructures being put up and actually being useful in the first couple of years, but then they start to degrade and not function properly, which then becomes a hindrance. And so the third recommendation is really focusing on assisting the sustainability of our societies, both by using technologies that assist in sustainability and making sure those technologies are sustainable in themselves. Thank you so much. And back to you, Yara.
Thank you so much, Dr. Ahmed. Now let's hear more about the S20's Foresight Task Force and Dr. Saleh Al-Baik. Dr. Saleh?
Yes, thank you, Yara. Yeah, so as we can see so far, the critical transitions that we are facing today are growing in complexity. So the main task of this task force was to go through the other task forces and compile the recurring themes and try to derive the main recommendations and call for actions from there. The work of this task force was compiled based on surveys, workshops, an iterative expert authoring process to attempt to go through this process of connecting the dots and deriving the best call of action from here. And the main recommendation for this task force is the concept of foresight or scientific foresight. This scientific foresight is based on the concept that we humans have agency over the kind of a future we want, and that there is some ability to predict certain outcomes that are bound to the constraints of economic institutions, political institutions, and technology, for example. This process, of course, requires a lot of engagement between many experts and many players in many domains. And the the recommendations eventually have to boil down into actionables that are aligned with the kind of future we want. Already in the world today, if we look, there are many countries who have already recognized the importance of having some form of foresight activities in their governance. Their level of engagement in this process vary in the nature and in the level, from processes that are dependent on the government, the public institutions, think tanks, corporations, and other groups. At international level, for example, we could look, for example, at the Horizon Scanning Program team in the UK. Cabinet Office, or even sometimes the foresight activities guide the government, but happen external to it. For example, in the National Institute for Transforming India. However, once we try to look at all these activities that happen across the board in the world, there are significant limitations and significant gaps from what we would hope to happen. One of the major gap and challenge in this process is related to the whole concept of complexity and the growing complexity and interconnectedness of the world that we have today. A lot of the decisions and a lot of the decisions that have to happen today, and a lot of the challenges that we have, eventually occur at different places, from different perspectives, and the decision makers eventually have to operate at different levels of visibility, authority, and control, in information availability, information quality, and so on. However, the majority of the foresight activities so far have the science component just as an ad hoc process, and not as a major central concept in the process. And so based on all of this, we came up with two primary recommendations. The first recommendation is to support foresight research that is based on robust science, repeatable methods, and open sharing, and incorporate recent advances in complex systems, network science, and AI. The second recommendation that we had is to establish a platform upon which to implement and foster international collaboration. Such a platform will help in bridging the divide and the gap that we have today to operate an interconnected system and interconnected world, and hopefully to establish a trust in the foresight methods that eventually become the norm. Thank you, Yara.
Thank you so much, Dr. Saleh. Thank you very much to everyone. I'll go back to Dr. Farah. Dr. Farah, you talked about the Future of Health Task Force, and you mentioned that one of the recommendations revolved around personalized medicine, which we know is a new approach to healthcare that mainly focuses on tailoring medical treatment plans based on each patient's genetic profile. Can you elaborate and tell us more? What are the major challenges facing advancements in personalized medicine, and how can we overcome them?
Thank you, Yara. So the whole idea of personalized medicine started after the completion of the Human Genome Project in the year 2000. So the Human Genome Project was an international scientific research project with the goal of mapping all the genes of the human genome. Here in Saudi, we have launched in the year 2013 the Saudi Human Genome Project, which aimed to sequence the DNA and identify the genes for 100,000 Saudi individuals, which led to early diagnosis of genetic disorder, which led to document the first Saudi genetic map, for example. A week ago, CACS has announced that phase 1 of this huge project has successfully been completed. So from there, the personalized medicine has emerged 20 years ago, in which scientists and clinicians found that current traditional therapeutic approach is facing several challenges, mainly related to their lack of specificity And personalized medicine is a fantastic approach to take a one-size-fits-all approach for diagnosis and prevention and turn it into an individualized approach. So they use individuals' genetic profile and in which this information or the data we acquire from the Human Genome Project in the first place. Many technologies has arisen the past 20 years from the Human Genome Project, and what we call them omics technology. Omics come from the word genomics. Similar, like for example, cell therapy, gene therapy, immunotherapy, nanomedicine, any therapy that is tailored to the patient genetic profile. Personally, in my research within the past 10 years, I would use these certain omics technology for my research. More specifically, I use gene therapy like CRISPR technology. CRISPR technology is a technology that won Nobel Prize this year. Two female scientists has discovered a gene, very powerful gene editing tools 10 years ago. So CRISPR technology allow researchers to easily alter the DNA sequence and modify the gene function. So for example, a cancer patient who has a defect in one gene, by using CRISPR technology, we can modify this defect, turn on the gene, turn it off, silence it, remove it, edit it, and so on. So by using this technology, we can treat so many diseases in the future or even prevent diseases from happening. However, we still face major challenges arising from such technologies. And the first and the major one is the cost. And I need to emphasize on this point. For example, there's a rare disorder, which is the spinal muscular atrophy. It is caused by defect in one gene. And the illness destroys the nerves that control the muscles. And usually newborns with a defect in this gene, they wouldn't live longer than 2 to 3 years. So a new gene therapy has been discovered in which scientists used genetically modified viruses that carry a healthy copy of the gene needed and replace the defective one. This therapy is already there, it's already in the market, it's already been approved by the FDA in the States. However, one dose of this therapy, which is enough to treat the disease, costs $2.1 million. So these therapies, even if we already find them, they are still not accessible for ordinary patient. And we need to, even to improve these technologies. CRISPR is a very powerful tool, but still we need to troubleshoot, work on it for more years to make it like a standardized approach in the clinic. We still have a challenge of insufficient fund and investment devoted to such research in these technologies. We still have a scarcity of scientists, institutional incapacity so far. So we need to promote translational science, in which some of these technologies are still buried in the lab and they need to make it to the clinic. We need to improve regulations to include these techniques in health plans to promote social acceptance of these new modalities, prevent their misuse. Some of the patients are still afraid of using these new technologies. Some of the clinicians are afraid to use them. We need to invest in rising highly skilled personnel, training program, more innovation when it comes to personalized medicine. So personalized medicine is the future. And I believe if we implement the new policies and regulations that we have proposed in our policy recommendations, this technology will be a standardized approach in the clinic to treat many of the critical diseases, I would say, within the next few decades. Back to you, Yara.
Wonderful. Thank you so much, Dr. Farah. I have another question for Dr. Burhan. Can you tell us why achieving circular economy is essential for the 21st century? Dr. Burhan, you're muted. You are still muted.
Sorry. Thank you, Dr. Farah, and thank you, Yara, for a great question. Okay, so in the first 21st century, with our stated goal of sustaining a strong economic growth, raising people's standards of living around the world, making them richer and reducing poverty, and sustaining a healthy population growth, economies around the world will need to use much more resources than any time in history. So resources like energy, materials, food, or water. The challenge is to keep growing and developing, maintaining a healthy population growth while living in harmony with nature and the environment. The goal in the 21st century is sustainable economic growth and development for our generation, kids, grandkids, and many generations to come. I will give you an example of a revolutionary product at the intersection of energy and materials that need to enter the circular economy to be truly sustainable and environmentally friendly: electric batteries. So electric batteries at financially feasible prices are needed to reduce the harmful emission from transportation activities and from our power generation activities. Their production is going to increase in an exponential way in two big sectors. The first is the transportation sector, mainly car and trucks for now, but maybe also airlines later. The second big sector is the solar energy sector. So it's needed to solve the problems of intermittency and unpredictability in solar energy and for energy storage during the night. So this is an equally huge market to the transportation sector. So within only 10 years, the will use more electric batteries in the transportation and solar energy sector, 100 times more than we use right now in our electric cars, the few ones we have, or our consumer electronics, such as watches, phones, or laptops. I'll give you some numbers to have a better understanding of this. I will only consider electric vehicles need for batteries. So the number for EV in the road is expected to increase 10 times from today. If you only assume 25% growth in sales over the next 10 years, from 2020 to 2030. Today, we have to recycle 1 gigawatt hour of battery capacity, but only in 10 years, we'll need to recycle 100 times more batteries with that conservative assumption. So 100 gigawatt hour. To give you a sense of what a gigawatt means, a half a gigawatt is the average size of a typical power plant. And a large economy like the Kingdom of Saudi Arabia uses a total power capacity that is less than 100 gigawatt. So in 10 years, for batteries just coming from electric vehicles, we'll need to recycle 100 gigawatt. So I recommend that decision makers in the private and public sector think carefully about how to ensure that these important products and other products like solar cells or even our use of fossil fuel when it emits CO2, and there are technologies to capture the CO2 to be truly environmentally friendly across the value chain of the product, from mining to manufacturing to recycling. So I will conclude by saying all major product cycles, whether batteries, solar cells, oil, or plastic, need to be a circular economy in an economically viable manner to be truly environmentally friendly. I hope that was helpful, Yara, and back to you.
Yeah, that was a very comprehensive answer. Thank you so much, Dr. Burhan. I'll come back to Dr. Ahmed. Dr. Ahmed, you led the team and headed the team working on the AI sub-theme in the S20 Digital Revolution Task Force. Could you tell us from your experience and role there, what were the main outputs and results of that group?
Yes, sure. Thank you so much. So we had a very useful set of discussions where we looked at all various challenges, and it was very interesting to see how different individuals from different backgrounds have a various set of objectives with regards to the problems that are faced with regards to AI. So we wanted to look at the critical issues within the AI domain, to avoid the setbacks that could happen from an efficient implementation of different governance or fairness or even objectivity standards. And so one of the discussions went into the concept of the Hippocratic Oath. If you think about it, when a medical doctor graduates from medicine or medical school, they take the Hippocratic Oath that says that they will do no harm. Why? Because they actually, over their career, they would handle thousands of patients and sometimes even have their lives in their hands. Well, right now, AI is being integrated into medicine, into even the judiciary systems and so on, and it's making real-life decisions. And so one of the concepts were actually discussed of why not actually have the AI experts, when they finish their studies, to take a similar oath that they should actually look at the do no harm thought process. So that was on that point, but also going into specific topics of ethics and how different countries and different cultures, they all agree on set of standards of ethics and morality, but there are some minor differences that are distinct for each culture. Differences like if there is for self-driving cars, they might have to make decisions with regards to people's lives, and how do you prioritize senior individuals versus different genders and so on. Different cultures have different values, and one way to think about it is organ transplant. The standards of organ transplant are not the same across all cultures. Different countries and cultures might have different standards based on what they believe is the right way to handle that. Similarly, AI, when it makes decisions, should have that consideration. And a thought that came out of that discussion was having an AI chip, or sorry, an ethics chip in self-driving cars that you can take out and swap based on the country that you're within or even the culture. I'll also go into other issues with that, but really it's about looking at how to avoid a setback before it happens. Not wait until there is a big issue that is happening because of a technology within AI, and then it would cause actually negative impacts that would hinder the progression of such technologies, but actually avoiding it. So a big point there is explainability. AI technologies, as I said, are making decisions in financial sector, health sector, judicial, and so on. A lot of the times, we need to understand why it reached a decision. If it makes a decision to say that this patient has this disease and so on, we need to know why did you make that decision so that we can handle it, maybe tackle the issue, look at the symptoms and so on. Or even if you look at sentencing in law, or even a financial decision, you should purchase this item and so on. Explainability is critical for people to be able to explain it and also make further decisions based on that recommendation. And so explainability was a big factor in our discussions and looking at how to advance explainable AI. And there are a lot of progress being made in that front, and we wanted to highlight it and make sure that it's not only presented but also analyzed in the right way. Last two kind of discussion points that we looked at, there was the important idea of decentralized AI. So right now, the concept of edge computing has a big impact on a lot of these entities and companies. It has, first of all, the concept of making sure that the data is not always centralized. So this is higher security. Your data might be actually stored within your device. It never leaves. The computation is done there. With all of the computation in all of our devices, you actually don't need to send and transmit your personal data. That has benefits on privacy. It also has benefits on efficiency. And at the same time, you can actually customize how you want your processes to happen. So this is on the concept of edge computing and decentralized AI and all of the benefits and helpfulness that it can provide for the various issues that are raised. Last but not least, given everything I've mentioned and all of the concepts I've talked about, you can see how the computational power of AI, or the computational requirements of AI are tremendous because of the fact that it's pervasive in all of our technologies and in all of our daily lives. And so the amount of energy consumption, going back to what Professor Burhan talked about, really are critical to consider. If you actually make a small improvement in your efficiency of the AI algorithm, you have a huge reduction in electricity and power consumption and computational time, and even the amount of resources that your technology would actually dedicate to you versus that computation. And so the concept of light AI is something that's already being advanced, and there's a lot of technologies by big companies that are produced for that front. And trying to focus on that and recommend it as a big area of investigation to push for would actually have huge impacts. So these are different domains that we discussed, and it was very valuable to have a wide set of opinions and look at all of the recommendations in that. And thank you so much for listening.
Wonderful. Thank you so much, Dr. Ahmed. You mentioned some really critical aspects, I think, that touch upon multiple topics that we're discussing here, but most importantly, the importance of being future ready. Are we future ready? Are we future fit? And I think that takes me to Dr. Saleh. Dr. Saleh, you mentioned in your opening remarks something about foresight. We know that most organizations conduct projection and planning activities, and usually dedicate a department or unit within their organization to utilize some sort of strategic insight tools. Can you tell us more and elaborate on how the foresight that the S20 is advocating for is different?
Yes. So that's true. Many organizations today, and as I said, many countries already employ some form of foresight activities that range from prediction of the future or even planning activities to guide the development. However, these methods that we have today lack at fundamental level, let's say, especially when we consider the level of complexity of the critical transitions that we have today. COVID-19 that we are going through today is a very clear example that we can look at to see the deficiencies of the foresight activities that happen today. For COVID-19 started as something that is localized. It's a pandemic. It's a virus that one would expect to have an immediate impact on the health sector. However, quickly we realized that it had an impact that spanned many other domains. For example, from healthcare, we started to notice its impact on online related to the circular economy, for example. We have seen the disruption, its disruption on the global supply chains. We have seen how we had to shift our manufacturing to accommodate the shortage of masks, for example, and the shortage of hand sanitizers at the beginning of the events. And then from there, we can also shift and see its impact on the digital revolution aspect from the spread of misinformation and many people questioning what information to trust and not to trust, and then all the way to our attempts to handle the healthcare crisis in our attempts to do tracing, for example. And we have seen many countries trying to implement methods that employ some form of digital aspects. And we have seen the many questions that started to arise from privacy to effectiveness. So from this example, we see how many of these critical transitions are not centralized within one area of expertise or in one country. It's interconnected. And all of these people have to interact together to be able to predict what's going to happen in the future. And when there is a room, and there's always a room to decide what to happen in the future and to try to plan, then those have to come together to do these activities. So when we try to inspect the foresight activities with respect to this example, for example, we see that all of the methods are not designed for this complexity, and hence they oversimplify the situation, and that leads us to so many processes of learning on the spot and trying to handle what we call the nth order effect on the spot, instead of being able to foresee it before it had happened and plan for it before it had started to unfold. The second challenge is related to the ability of these methods to handle quantitative analysis. Many of them depend heavily on qualitative analysis, sometimes even from experts, but still they are qualitative analysis. Today, we have been through what's called the data revolution. A data revolution that provided tremendous amount of data. This data is not being utilized effectively, not for prediction of the future, and definitely not as effectively for planning for the future. We can also consider the fact, again, as I said, for us to do scientific foresight and effective foresight, we need to have an ability to decide and to predict across all the task forces that we have today, or across the many domains that the critical transitions involve. And the methods that we have today are definitely might employ an attempt to integrate multiple opinions, but it just happens at a simplified layer. However, if we look at the recent advances in scientific methods, we could see advances in complex systems and complex sciences. There are advances in network science, there are advances in AI, simulation, compute methods. All of these methods, when we put them together, are at a stage today for us to start to employ them at a more active layer and at a more active investigation in a manner that we hope could resolve many of the issues that we have today.
Wonderful. Thank you so much, Dr. Saleh. I think we have a few more minutes to utilize, and I'll just ask you all, go around, and in less than 1 minute, can you tell us what can we learn from the current COVID-19 crisis? I'll start with Dr. Farah.
Well, I believe many lessons we've learned so far. First of all, we need unified responses to pandemics rather than the diverse, disconnected strategies. So far, there has been little evidence of international coordination. Countries have moved at different speeds and intensities. Some countries have similar disease curves and reacting very differently. And these responses usually seem to be disconnected from any epidemiological evidence. So we urge countries to implement a comprehensive response to pandemics by sharing, of course, data and reports and increase transparency between countries. Also, we need to test the responsiveness and resilience of the healthcare system worldwide and make changes and improvement based on the results. Healthcare is essential to respond to such a pandemic. And as COVID-19 has spread across the world, health systems have been shocked and found to be underprepared in certain countries. In Saudi, the healthcare system showed to be very strong and responsive, but in other countries, they lack a hand shortage of drugs and ventilators, for example. So once the current COVID-19 pandemic is under control, health systems should be tested just like banks or any other entities to ensure that they are resilient and that any weaknesses are being addressed and fixed for any future crisis. Back to you, Era.
Great. Great. Thank you so much, Dr. Farah. Dr. Burhan, can you tell us in less than 1 minute, what can we learn from the current COVID-19 crisis?
Okay, thank you, Yara. So as Dr. Farah said, we know that these pandemics have been increasing throughout the years, especially in the last 50 years or so, and that they will hit back with huge uncertainty about, one, their lethality, two, about the speed and method of spread. So I'm going to add to what Dr. Farah said. I'll make 5 points. First, we need to study viruses and epidemiology, the basic science and applied science more. And so we can learn about these evolutionary processes and why they happen and why they are increasing. And we need to get better at modeling pandemics and finding the key parameters that move them. Second, we need to more take to find a cure or to alleviate and reduce the symptoms of the disease around the world, so the new drugs are accessible to everyone, not only for developed countries. Third, we need to also sponsor and do more research about vaccination tech, how we can develop vaccination in a quick way and make it accessible for everyone. Fourth, we need to develop new technologies to reduce the spread of pandemics, engineering technologies, so products, so maybe better thermal cameras at airports, or maybe UV LED disinfection. Fifth, we learn, and we've proven that we should learn how to get even more resilient by relying on modern information technology, such as video conferencing and the internet, to carry out our business and innovate, regardless of our ability to gather and meet each other.
Great, thank you so much, Dr. Khan. Dr. Ahmed, tell us, what can we learn from the current COVID-19 crisis?
Well, there is actually a lot of lessons, and I think Dr. Farah and Dr. Burhan already mentioned quite a few important ones. I'll mention one that actually I felt most entities already found out the hard way and learned, and so I would like to share that. Before the epidemic, if you go back to 2019, many entities looked at digital technologies and automation and so on as an important next step that they should take to increase their efficiency and profitability and so on. What's not was not expected was how, if you didn't do that, entities that were slow in adopting those technologies suffered greatly during the epidemic, to the point where now most of them are actually scrambling to just apply any types of technologies they could find. And so these technologies are not like the norm where you have to balance between efficiency or robustness. They are ways that can enhance both if done correctly. And I have to say that it's been a very interesting thing to witness how so many entities and companies and businesses are right now adopting so many technologies that are going to have a positive impact even after the epidemic.
Oh, absolutely. It's been said that this crisis, there's a silver lining, that it has somehow accelerated a lot of non-accelerable aspects of technology and increased the adoption of that. Now, Dr. Saleh, tell us from your own perspective, what can we learn from the current COVID-19 crisis?
Primarily that there is a lot for us to work on to prepare in terms of foresight for the future. The virus started in one city in the world, and then with international flights that transport people within hours across the board, it started to spread much faster than anyone could have prepared, and anyone could prepare any analysis or studies or planning. The sufficiencies of our foresight struck us by surprise eventually, and although the triggering mechanisms of the virus is hard to predict, the spread mechanisms are hard to control. However, if we see the many struggles that we have been through over the year so far, they are disconnected from the particularities of the virus. A lot of the decisions and a lot of the strategy that we had to develop are strategies and concepts that we could have studied in advance, in a way that when when time mattered, we could just go back to all the plans that we had to accelerate the process of strategy development and handling of these crises.
Well, wonderful. Thank you so much to everyone. Thanks to our panelists for this great conversation and for the great overview of the S20 process. And thanks to everyone for joining us today. It's time for everyone, and specifically for the science community, to work together, increase the efforts in engaging effectively, not only with decision makers, but also increase the dialogue with the public to increase the awareness and understanding of science and technology. Once again, thank you very much for joining us today, and have a great evening. Goodbye.